last thing we are going to be doing in this chapter is Simpson's rule, which is a slight variation of the trapezoidal rule. So if you understood the trapezoidal rule and the process involved there, this is not much different. In fact, the denominator is pretty much the only thing different of the number you're multiplying the whole thing by. But just to kind of give you an idea of where this English mathematician is coming from, instead of dividing things into trapezoid, he divided them into polynomial expressions. Generally no more than a square. So these are basic quadratic equations. So the function of x in terms of this polynomial, use p for polynomial, ax squared plus bx plus c. And his derivation started off by taking that polynomial and integrating it, and then he came up with this thing, or a better way of putting it, with a combination of the a and b and various permutations here, it looks like. But when you condense all that thing down, it's b minus a over 3n now, and then the pattern, instead of being 1, 2, 2, 2, 2, 2, 2, 1, it's now 1, 4, 2, 4, 2, 4, 2, 4, then 1 for the coefficients of all your segments functions here. So this only works for even numbered n's. And like I said, this is the pattern here. So if we take a look at this particular example, the value of b minus a over 3n, in this particular case, again, we're going to divide this into 4 sections. So the change of x is pi over 4. So we have slices of pi over 4 in differences between the two heights, or whatever you call it with polynomials. And now we use pi over 12 because pi minus 0 is pi over 3 times n, which is pi over 12. So this becomes the same basic process of pi over 12 times the sine of 0, but now a 4 here for a coefficient, plus 4 sine pi over 4, plus 2 sine pi over 2, plus 4 sine 3 pi over 4. And since that's the last term, you're just going to have a coefficient of 1 here, sine pi. So it has to end with 4, 1. So when you do all that, and you get 2.00. So I don't know how much better that is from the actual one, but that's all there is to this. So if you did trapezoidal rule without any great consternation, this is not going to prove to be that much different, just a slight variation. Practice problems 12 through 18 on page 314. Have fun.